without wasting much time, let's go on to apply the substitution method to these two examples here, example 1 and example 2. So it's easier and much more convenient to apply the substitution method to simultaneous equations in which the variable or a particular variable might have a coefficient of 1 or minus 1. In equation 1, for example, of the equation 1 of the first example, x has a coefficient of 1. In example 2, the second equation, y has a coefficient of 1. So it makes it very convenient to be able to apply the substitution method to these problems. Okay, let's go over to the solution space. There's example 1 recopied here. And the first equation named equation 1. The second equation is named equation 2. So for that variable that has a coefficient of 1, which is x in this case, we make x the subject of the formula, and then we substitute its value, its equivalent value for x in the second equation. That's why it's called substitution method. To substitute means to replace something with another. So let's just delve into that. We can say that from equation 1, x is equal to minus 4 minus 2y. That if we make x the subject of the formula from this equation, we want only x on the left hand side. So subtract 2y from both sides. So you have a negative 2y also on the right. That rearranges the equation to this: x equal to minus 4 minus 2y. This means that x is equivalent to minus 4 minus 2y. You can, in place of x, substitute minus 4 minus 2y. So then we substitute minus 4 minus 2y for x in equation 2. So we made x the subject of the formula for equation 1, and then we substitute it into equation 2. This means that wherever you see x in equation 2, put minus 4 minus 2y in place of x. Okay, this is basically 2x. Let me rewrite the original equation 2 just above it so you understand and relate better. 2x plus 5y equals to 1. So 2x plus 5y equals to 1. All right. Obviously, it's obvious to see what should be done here. Expansion. So expand by using the value outside the bracket to multiply everything in the bracket. 2 times minus 4 is minus 8. 2 times minus 2y minus 4y plus 5y equals to 1. All right. Okay, basic algebra. We want all the y terms on the left and all the constant terms to the right. So what we do here is add 8 to both sides. So minus 8 plus 8 goes to 0. And then you have 1 plus 8 on the right hand side. So minus 4y plus 5y is equal to 1 plus 8. Minus 4y plus 5y is just a single y. And 1 plus 8 is equal to 9. So we have the value for y. Let's proceed to find the value for x. We can simply substitute 9 for y in any of the equations at all. Let's go with equation 1. So wherever I see y, remember the original equation 1 is x plus 2y equal to minus 4. So in place of y, I'm putting 9. So x plus 2 times 9 is equal to minus 4. This means that x plus 18 is equal to minus 4. X is equal to, subtract 18 from both sides, minus 4 minus 18, which is then minus 22. So So the solution to this Pelf simultaneous equation, the values for x and y that satisfy both equation 1 and 2 are x is equal to minus 22 and y is equal to 9. I hope we get it. So let's proceed to example 2 for a better understanding. Just going to rewrite it out here. 7x minus 2y equals 45. That's the first equation there. So we'll name it equation 1. And next, 5x plus y equals 37. This is equation 2. Alright, so I can conveniently apply the method of substitution. Look through equation 2. You can see that y has a coefficient of 1. So make y the subject of the formula just by saying from equation 2, y is equal to 37 minus 5x. We understand how that works, right? It's a positive 5x. So subtracting 5x from the both sides, it goes to 0 here. 5x minus x is 0. And then we have 37 minus 5x on the right-hand side. So we can then substitute Substitute 37 minus 5x for y in equation 1. So we made the subject of the formula from equation 2. We made y the subject of the formula, and we're substituting that value into equation 1, meaning that in place of y, wherever you see y, you replace it with 37 minus 5x. This is the original equation 1. So 7x minus 2 in place of y, I now replace with 37 minus 5x, all equals to 45. So 7x, what can be done is easily seen here. Expand the bracket, minus 2 times 37. That's minus 74. Minus 2 times minus 5. So minus times minus becomes plus. 2 times 5x is 10x, all equal to 45, which was what was on the right hand side from the beginning. Follow me closely. Okay, so collecting like terms, this is a term in x, this is also a term in x, 7x plus 10x. And then all the constant terms should be on the right, subtracting 74 from both sides. Adding 74 rather. This is negative 74. So we add 74 to it. So 74, positive 74 minus 74 goes to 0. And then since we are adding 74 to the left, we're also adding 74 to the right. So 17x is equal to 119. We then divide both sides by 17, since we're trying to find the value of x. So 17x divided by 17, also 109 divided by 17. 119, not 109. 119 divided by 17 is 7. So that's our value for x, 7. So put 7 for x in any of the equations in order to help us find y. So in place of x, I'm putting 7. Let's work with equation 2. In equation 2. Alright, this is the original equation 2. 5x plus y equals 37. In place of x, I'm now putting 5 times 7 plus y equals 37. 5 times 7 is 35 plus y equals 37. So in order to find y, this is a positive 35. You do the opposite, which is to subtract 35 from both sides. So 35 minus 35 goes to 0. And then you do that on the left, also do that on the right. 37 minus 35. You then have your y to be equal to 2. So the solution set that satisfies the simultaneous linear equation, that satisfies the pair, both equation 1 and equation 2, is x equals 7 and y equals 2. That is the substitution method. Thank you for watching. Anticipate the video on elimination method. Bye.